All right, so I think that I may have done this problem with you yesterday, but I wanna make sure I get it on video, so we're gonna run through it real quick. And that is number 6, where it says find the direct algebraic relationship between these. Do you guys remember what we did yesterday? What did we do? What does this direction find a direct algebraic relationship between x and y? What does that mean I'm supposed to do? Eliminate the t's. So, do you remember how we did that yesterday? What did we do yesterday? If we're gonna add these together and eliminate the t's, what are we gonna have to do? We multiply the top equation by -2. And then when we added, those canceled, and we were left with a -2x plus y on this side, and -11 on that side.
Where does the negative come from? Is that from the 2t?
And I need to make those t's cancel out. So, since one of them is originally it was a plain t and the other one is a 2t, if I multiply by -2 to make that a -2, then when I add them, they'll cancel. It's regular elimination, like you've done all along. All right, now the next one says, so that's the answer. That's it. As soon as you get the t's gone, you are done. Because there's your equation with x's and y's. All right, now the next one says, are these inverses? A real easy way to check is to remember what it means to be inverses. Inverses undo each other. Okay? So what that means is, if you stick a 7, and I'm making that number totally up, if you stick a 7 into function f, what do you cut? What do you get out? You put a 7 in, you get a 10 out. Now, if this is the inverse, then when I put the 10 in here, I will get a 7 out. That's what it means to be an inverse. If you put a 7 in the first one and get an answer, then put your answer in the second one, you should get your 7 back again. So does that happen? If I put a 10 in here, what do I get? 9. So are they inverses? No. So they are not inverses because, and if the notation bothers you, you can use words. When I put 7 into f, I got 10, but when I put 10 into G, I didn't get 7. If things are inverses, let me show you an example. How about if these were my functions? F of x equals 2x plus 4, and g of x equals x minus 4 over 2. Now, let's put 7 in this one. If I put 7, and I'm using 7, you can use any number you want. If I put 7 in here, I get 18. Would you agree with that? Now, take the 18, take the answer, and put it into this one. What happens? 18 minus 4 is 14, divided by 2 is 7. That's inverses, when that happens. Now, it doesn't have to be 7. You can pick whatever number you want. I would stay away from 1s and 0s because those are kind of special numbers, but any other number. So, if you want to put in, I don't know, 20. F of 20 is, let's see, 44. And then if I put that 44 into G, What's 44 minus 4? 40 divided by 2 is 20. See how that works? If they're inverses, you have this relationship. So pick a number, plug it into the first one, get an answer. Take the answer, plug it into the second one, and you should get your original number back again. Got it? Okay. This one they weren't because that didn't happen. This would have had to have been a 7 and it wasn't. All right. Now we're going to find some inverses. So we took a quiz over this actually. Problem B was a quiz. So first thing I'm going to do is write this problem with a y. So I am finding the inverse. In number 8, I am finding the inverse. So I made my f of x a y. Remember that? What's the next step?
Switch the y.
Switch the y and the x. And this is an easy one because there's only one y. So I'm going to get it by itself. So I'll multiply by 4. Subtract 9. And divide by negative 2. And then I'll write my answer with function notation. So f inverse, that's my job, that's what I was doing. So f inverse is 4x minus 9 over negative 2. So what are our steps again? We turn the f of x into y, switch the variables, and then get y by itself. Now that's not too bad for that problem. It's a little harder for problem B. So you took a quiz over this. Let's see if you remember what to do. I'm going to go ahead and change that to a y. All right. What happens now? Switch the variables, just like we did over there. Switch the variables. But Izzy, every x becomes a y with the right numbers. Okay? Now what? Times this guy over to here. And that's going to be a distributive situation. Some of you do that in your head, and that's fine. Just remember to distribute. Okay, everybody with me? Now here comes, this is kind of the step that's easy to forget if you haven't practiced. What has to happen now? No, we don't do any factoring. What do we have to do? Josh?
Don't you take out the, you have to get the y on the same side.
Exactly. These two have to switch places, remember?
So you do plus 3,
So 2xy
plus 3, or minus 3y
minus 3y
equals negative 4x minus 5.
Perfect.
And then you take out the y.
And then we take out the
And after
y.
you take out the y, you just rewrite it again, taking out the y, and then you do divide it by 2x minus 3.
Exactly.
Then you put it in the notation.
Exactly. Good job. Good job, Josh. So let's make sure everybody else is up to speed on that. So we changed our variables, brought this over and distributed. Then we had to get our y's on the same side. So we flip-flopped these two. And when we move them, they become negative, or they change sign. So this became negative 3y, that became negative 4x. Then we could take out the y and then divide by the parentheses. Perfect. All right, is that coming back to you? Test question. All these are test questions. Okay, so I have x equals t squared, and I have y equals 5 plus t over 3, and I know t is -1, and my job is to find x and y. I'm finding an ordered pair. This is so easy, this is the easiest question on the test. What do we do? Plug in -1. So my x, this is my x, this is my y. If I plug in -1 for t, what does x equal? 1. And if I plug in -1 for t, what does y equal? Perfect, done. That's it. Plug it in, whatever it is. The equations on the test will be different, the number will be different, but you do it exactly the same way. Plug it in, get your point. Do not miss that question. That is an easy one. Okay. Now I have some random graph, and I'm going to do some stuff with them. Okay. Now I'm going to look at all these questions because there's a bunch of them. So I'm going to sketch the inverse, so I'll do that in a minute. We'll look at these other questions. Is this thing right here, this picture, is it a function? Is that a function? That thing right there?
Yes.
Yes, why?
The
Passes
vertical line.
the vertical line test, right? Is its inverse a function?
No.
It fails the horizontal line test. Remember, if you're checking on the inverse, you do the horizontal line test, and think about this line right here. Wouldn't that cross twice? Wouldn't that one cross twice? It fails the horizontal line test. So is it 1-to-1? No, because it doesn't pass both tests. So you're gonna do a little review here. We talked about all this. Hopefully that sounds a little familiar. If the original is a function, do the vertical line test to check. For the inverse, do the horizontal line test. And then if it passes both, then it's 1-to-1. Okay, it's gotta pass both. All right, now let's actually sketch the inverse. Anybody remember how to do that? How to sketch the inverse? Well, let's go through and label every one of the original points. So this is -4, 0. This is -3, -2. I'm just labeling the points on my graph. -2, -1. -1, -1. The origin. 2, 1. And 3, 0. Does anybody remember why I'm doing that? Why am I labeling the points on my graph? Lewis?
Wouldn't you switch like
No, I
the
switch them.
-4 to
Yep.
0,
Bingo. Remember when you did your equations, how you flip-flop the variables? That's what you do with your picture. You flip-flop the variables. So Lewis is right. Instead of plotting -4, 0, I'm gonna plot 0, -4. You don't have to label that unless you want to. And then I'll do -2, -3. And then I'll do -1, -2, -1, -1 in the origin. So far, that's what I have. Does that have the same shape as this? Yeah, except instead of being on the x-axis, now it's on the y-axis because I switched the variables. Okay, then I'll plot 1, 2, and 0, 3. And there's the inverse. There was a homework question like that, and some of you missed it in those papers I turned back today. So you might want to take a look at that and make sure you remember how to find your inverse. Jared, was your hand up for something?
No.
What's that? Oh, Daryl, sorry. Wyatt.
Is an inverse still a function?
Is this a function?
Yeah, is it still a function or no?
No. If
Okay.
it fails, if the original fails the horizontal line test, then your inverse won't be a function.
Okay.
This doesn't pass the vertical line test,
Okay.
right? All right, so one more to go. Okay, so I have drawn a picture, and you have to figure out what happened. So I actually drew two pictures. So my starting picture has the triangle and the semicircle, oh, that's not right, has the triangle and the semicircle and the other triangle. So that's the original. Now, you have to figure out what happened to this picture. So can anybody tell me any of the changes? Let's just make a list of the changes. What happened in going from the original to the new one? Upside down? Okay, anything else happen?
And left to right.
And a sideways flip?
Yep.
So let's make sure everybody's on the same page here. Would you agree that in the original, the semicircle and the small triangle are on the right, but they're on the left on the other one. So yeah, it flips sideways, and everything's upside down and how it was. Perfect. So what's my equation look like? Y equals what? What did I do to my equation? How do I do it upside down?
Is it the negative front?
Negative in front, so this would be negative f of x.
No.
I didn't do absolute value. Now, how do I do a sideways flip? Anybody remember how that happens? In the equation, what do I see that causes a sideways flip? Jared?
Is it the negative from the x?
Exactly. So there's your equation. So this is a much harder exercise because you have to, first of all, figure out what happened, and then you have to remember what in the equation makes those things happen. So this is your upside down flip, and that is your sideways flip. All right, here we go, practice test 2, good job. Let's start with another page of graphing. This time, our base graph is 1, 2, 3, 4, a trapezoid. Like that. And a little semicircle. Like that. Everybody okay with our base picture? So now what are we doing? Well, let's look at A. A says this. We just talked about that negative. What does that negative do there? Sideways flip, right? That's going to cause a sideways flip. What does the 2 do? Actually, it's not the height, it is the width. It divides the width, the x. It divides the x. So, if I do this, I'll try to do it all at once. What is this x coordinate right here? -4. I'm looking at just the x. I'm going to divide that by -2, so it's going to give me 2. So there's the flip, see? Now, How about the origin?
Stays.
Stays the same. 0 divided by anything is just 0. Okay, how about this? This is the point, x is negative 1, y is 2, but x is negative 1.
2.
Negative 1 divided by negative 2 is 1/2. Now the y didn't change, so it's up there. This one is negative 3, 2. Negative 3 divided by negative 2, 1/2. So there's your trapezoid. I did a point by point, you don't necessarily have to do that. What happened to the trapezoid? It flipped over to the other side and it became half as wide. It's the same trapezoid, half as wide, divided by 2. Flipped because of the negative. Alright, now what about the semicircle? What's gonna happen to it?
Go up to
It's gonna go this way, right? And instead of being 4 across, it's only gonna be 2. There you go. You can do it point by point if you want, or you can just understand what the numbers do and then sketch it that way, if you wish. All right. How about this one? What's happening here? 2 things. What's happening? Taking the absolute value, and then we're moving it up 1, right? So, what's this transformation? There's 2 kinds of absolute values. What does that one do?
Is it like new dice?
No, that is negatives become positive. So, bottoms up, bottoms go to the top, the bottom part goes to the top, negatives become positive, however you want to think about it. So when I look at my original picture, the trapezoid is already up, so it is not going to change. But the semicircle is going to have to come up. Would everybody agree with that? I'm not done, but that's the absolute value part. Righto? Alright, now take the whole shebang and lift it up 1. On your graph paper, that's easy. Everything goes up 1 number, 1 block. And you have that green thing as your answer. Okay? Okay, we already did one kind of like this. What did we say that number's going to do? What does that impact? That impacts the width and it divides it. Remember when it was a 2, it divided it? So this is, we're gonna divide the width. Now, that means that every x is going to be divided by a half. Wait a second, guys. What's divided by a half means? Divided by a half is the same as times 2? Isn't dividing by a fraction multiplying by its reciprocal? Wow, okay. So that means, okay, what's this point right here? 4, 0. So if I take 4, my x's, this is x's, and divide it by a half or times it by 2, isn't it going to be clear out here at 8? So my semicircle is still just 1 down, but it's 8 across, that doesn't look very good, but you know what that's supposed to be. And then what about my trapezoid? Isn't that point gonna go clear out to -8? So there's my stretched out trapezoid. So that point was at -1, now it's at -2. Okay, what do you think about this one? What's gonna happen here? The height or the y's are gonna be multiplied by 2. And the height is y, so your y's this time are gonna be multiplied by 2, so you're twice as tall. Alright, what else?
Maybe everything left 3. Or right 3.
Okay, left 3 or right 3?
Left 3.
Left 3?
No, right 3. Minus
Right
right.
three?
Minus the right.
Yeah, I don't know, are we right or left? Are we good with right?
Yeah.
Right? Okay. So the whole picture is going to move, the original picture is gonna move right 3. So the circle, which started at the origin, is now going to start over here. Would you agree with that? So, is it the same size? Yes, except it goes down twice as far as it did before. How does that look? Is that too much for you to do all at once? The semicircle, it was down 1, so now it's gonna be down 2. And it started over here at 3.
So when there's like multiple steps, and for this case, like we have the times it by 2 and also move 2 by 3. How do you know which step to do first?
It PEMDAS.
Okay, so that's why we're doing 5, 3.
Yeah. Okay, some problems it doesn't matter, but to be safe, always do PEMDAS. Then you'll be safe. All right, now what about my trapezoid? Well, I'm gonna tack it on there. But it is going to be how tall? Originally it was 2, so now it's gonna be 4. So there's my trapezoid. Remember that this number only affects the y's. So that's why that's why it came up 4 and down 2. And got shoved to the right. Okay? One more graph and we'll be done with this page. What's happening in this one? Lots.
Absolute value for sure.
Okay, so what's that absolute value? There's 2 times absolute value.
Going up.
What's this one?
Where this stuff is.
This one's where we
You're to keep the right side.
keep the right side and then redraw it on the left side. So I'm gonna do that first. So my right side looks like this. And then I'm gonna just repeat it over here on the left side. Now that took care of this right here.
That was -2 with the width or the height.
-2 with the height.
Yep.
So that means it's gonna flip it all up and it's going to be twice as tall. This is a height number. This does the same thing that does, it stretches it. But because it's negative, it also flips it upside down. Well, this whole thing is down, so it's gonna go up, and it's gonna go up 2. So the green is the answer to the question. Alright, now we got our box problem. Okay, so here we go. The only thing that's ever different about these box problems is the dimensions of the paper. This one happens to be 10 by 16. That does not change the way I do the problem, right? So, step 1, write an equation for the volume of the box.
Yeah, 10 minus 2x, and then 16 minus 2x, and then x.
Perfect. Jack knows what he's doing. At least for that far. Right?
Oh yeah, I was thinking.
That's it. That's your equation. It's that easy. Now I need my domain, which is my x min and x max. What is that gonna be? Min to max. 0 always is the minimum. And in this problem, the maximum is 5, because the max is always half of the smallest dimension. Now, it's not a question, but before I go to my calculator, I need to think about what are my y min and y maxes going to be. So I gotta set my window before I hit graph. Y min is always 0. The minimums are always 0. And y max, what do I do with that one? Just 1, so what do you wanna guess? 600? Okay, now, if that's either gonna be perfect, or it's not gonna be big enough, or it might be too big. Okay, we'll just see when we type it in. Alright, so go to your calculator, y equals, clear out the old, put in the new equation.
Is that the volume? That's the equation.
Yes. Fix your window to fit this particular problem. And hit graph. Now, what's the deal? What do you need to see? Where's your calculator?
Wait, what would I change over?
We have already talked about all this. There's x min, there's x max. Do you have a calculator today, Jack?
I did.
No,
I
you
brought
don't.
my counter, but it's in my car. And I was
Well,
I was
we're
in-
getting
I was
closer,
in-
but not good enough.
Yeah, I was in a rush.
Parents are getting emails. I'm tired of messing with this. You have a calculator? Hey, Sean? Where is it? Alright, so I see my mountain. It's kind of a short mountain, but that doesn't matter. As long as I see the top, I'm good. So second calc, maximum. Set my left bound anywhere over on the left side of the mountain, hit enter. Move it over to the right side of the mountain, hit enter. And then to the top of the mountain. And every time you do this, the bottom of the screen, here's my mountain, the bottom of the screen is going to say maximum. You do not have the answer until it says maximum. X equals and Y equals. This question says the same thing that last one did. Find the maximum volume of the box. So one of these numbers is the maximum volume of the box. What is it? 144. So the answer is 144 cubic inches. That is your maximum volume. Now, what is this number, which by the way would get rounded off to 2?
The size of that.
That is the size of the corners that I cut out. That could be a question. It could say, how big are the corners? And then you would say 2 inches.
If you put in a different number, like you know how you put in 600 for Y max? I did it like before you made up 600 and I put in 700
Okay?
and I still got the hill, but then that made the maximum number a little bit different. Or not the like my number says X equals 2.00012.
Oh, that's okay. That's
So I
still
just
2.
round that.
It's still 2.
That's still 2.
It's still 2. It should have said 144.
It did. It still said 144.
Okay. All right, number 3. Gonna buy a restaurant meal. So Josh's point is a good one. I went with 600 for my Y max because that's what Sean told me to do. Could I have gone with 700? Yes. Could I have gone with 300? Yes. Right? There's no magic number there. You just need to make sure you see your hill. All right, so my meal costs $16.55. Okay. I'm going to make a couple of adjustments. I have to pay tax, and I have to pay a 20% tip. Now, tips get added on, right? That's not a discount, that's extra. So since these are both extras, they're both gonna get added to 1. So what am I gonna multiply by? 1.07. 1.20, yep. Yeah, just type it in. And $21.25 is what that will end up costing me. So the key thing to remember there is, we never multiply by the percent. We either add it to 100 or we subtract it from 100, depending on whether it's an add-on or a takeoff. Okay, number 4. How much 28% Kool-Aid? What's my, read that question, what's my general formula so I get this guy done? What's amount times percent plus amount times percent equals amount times percent. So these are all multiplied. So this times this plus this times this equals this times this. So my percentages are 0.28, 0.10, and 0.22. I know one amount. The amount I know is 20 cups of 10%. So it goes right here. 20 times 10. I need to figure out what the 28 is. How much is there of the 28? So I'm going to mix this plus this and end up with how much of that?
X.
Plus 20. I normally write 20 plus X, but it can be X plus 20. It makes no difference, whatever you want. All right? then you're probably gonna end up having to finish this on your own. See if I can do an answer really quick. Ooh, I made a mistake, I made a mistake. Oh, it should be just, yep, so this is. So the answer is 40 cups.
Where'd you get the point 28? Oh, okay.
Okay, guys, I want everybody back in your seat for a second.